Hello everyone, April the 8th. Alright, let's get down to it. Number of students unable to eat lunch. School cafeteria offers circular and square sandwiches. Circular and square. Also selling Q either prefer square or circular. The number of sandwiches in the cafeteria is equal to the number of students. The sandwiches are placed in a stack. If a student at the front of the queue prefers the sandwich on the top of the stack, they will take it and leave the queue. Otherwise, they will leave it and then go to the queue's end. This continues until none of the queue students want to take. This continues until none of the queue students want to take the top sandwich and thus unable to eat. You're given two integer arrays. J1 is in front of the queue. Return the number of students that are unable to eat. So students is this is the front of the student, and this is the front of the stack, right? Because it says I equal to 0 is the top of the stack, and j equals 0 is the front of the queue. So this student want 1, we have a 0, so this has to go back, has to go back, and then we had a 0 out, okay, and next 0 go back, and then we have a 1. Okay, so what I think is it doesn't really matter, right? Because if you don't want to eat, okay, here's what I think. If you have the same number of 1 and 0 in both, then they will definitely eat all of them, right? Because it doesn't matter. If the current round, it doesn't fit me, I can always wait for my round and somebody else can eat, right? And yeah, so I think the answer should be how many mismatches, right? How many mismatches? So we count the number of ones and count the number of zeros. And then we will say the number of students minus the number on the sandwiches. So in this case, I have 4 ones and 2 zeros, right? 4 ones and 2 zeros. So 2 0 will definitely hit, but the 4 ones, I can only hit 3, right? The 4 ones only have 3, but the answer is 3. What? Answer is how many numbers that are unable to eat. How is this 3? Like 1, I hit. This is a 1 go to the end, 1 go to the end. Now I have 0 0 0. Oh, we hit these 2 zeros, and then we have a 0 blocking all the other students. Holy crap. Alright, I thought there's like a math solution. I feel like you just have to do it, just simulate it, right? There's no any other way except from simulation. So as long as there are another one left, then you can always, right? You can always move forward. So basically, I'm trying to see if we can do it without simulation, but I don't know. It's doesn't seem to be like possible, does it? Can we do it without simulation? Let's just simulate then. Yeah. So on sandwiches, we can just use a pointer, but on students, we kind of, do you want to make it into a queue? Or can we do it without turning into a queue? Alright, let's just do it as a queue. Don't care. Just do it as a queue. Yeah, maybe there is a better way. I don't know. How do you do queue in Java? Do I do just a queue? Integer queue? Nope. Redo. This is actually not right. New what? Array deck. Oh, maybe I can do deck. There you go. Now I say for int s of students push. Let's do this. Well, do I do this way? How do you know when it's the end? Yeah, good question. How do you know? Then you have a count. You still have to have a count. No, what I think we can do is smaller than sandwiches length. Okay. And for each one, we're gonna go through the queue. Okay, I'm gonna go through the queue, and yeah, I can say for j0 j smaller than q dot size. Okay, j plus plus doesn't matter. So for each one, we can just say if q dot peak equal to sandwiches I. Right. If that's the case, then q dot poll first, and then I plus plus. Alright, I shouldn't do this. I just should be I equal to 0, and say while I smaller than sandwiches dot length. Okay. So if that's the case, we remove the front, and then we do this, right? And then else, if the front is not equal, then you can say q dot push q dot pull first. We remove the front and put it at the end. And then we go through the size, which means we go through the only that number, right? We go through every single one. Right, we go through every single one. Now, once we go through every single one, if nothing has happened, right? If nothing has happened, then we shall say, yeah, it's a bad, right? So every time it happens, I will go forward and the Q will be like, it will reduce Q, right? It will reduce Q. So I shall say int initial length shall equal to Q dot size, right? After we go through this, and you can say if nah, that's fine. So we'll get out. I'll just say if initial length is equal to q dot size, that will break. Right, that just means nothing gets popped. Right, and then we get out, we shall return I is equal to, oh no, once we get out, because we want to know who has not eaten, so we can just return q dot size, I think. I don't know, this one just feels very convoluted. I hope at least it's right. And the answer is no. It's interesting. Oh, yeah. But no, I go through every single one. Right, I'll go through every single one. And I compare to the front, right? And then I say j dot peak is equal to this, no. So this I say I'll push, so it'll be this. And then I go to the second one. And then go to the third one, right? Go to the third one, and I pull first, and I move this forward. Maybe I should break here as well. Nope. Huh. Maybe I should just say initial length. Maybe this is where the problem is. Nope. What the hell? Wait, is it the pull first? This one does get rid of the thing, right? Retrieve, remove. Yeah. It removes it. How is this not working? I don't understand. I don't understand at all. Still not right? No. What was wrong? Yeah, initial queue size is 4. And then we return 3, which means I did get 1 popped. Right? This is not so else queued out push. Right? So we pop this, we push. Pop this, we push. And now there is the same. So I plus plus, and then we break. Right? And then it's 3, not equal to 4. So we don't break. So we go to the next one. So initial length is 3. Now it's 0, 1, 1, right? 0, 1, 1. And then so I put a 0. Now they who pushes, and then I have a 1. Yeah, I don't understand. I have no idea why it is not right. I'm doing alright. Tired today. I feel like I'm very easily tired these days. And this one I need debugging. I don't know why. It's just not working. No idea why it doesn't work. It's alright, I'll just debug it. Let's debug this stupid thing. Alright, let's debug this stupid thing. Wait, why I have this? Wait, what did I do? Oh, we have to delete this whole thing. We have to delete this whole thing. Alright, let's set debugger here, and then... My god. I'm curious. No, I'm curious why this doesn't work. It doesn't make any sense. 1, 1, 0, and 0, right? Sandwich. What's sandwich? 0, 1, 0, 1. 0, 1, 0, 1. Okay, this is going to be count students. Students and sandwiches. All right, let's debug this. Whatever the hell is wrong. Let's see. I'm gonna go F8. I is 0, sandwich is 4, okay. And then initial length is 4, okay. So Q, what's Q? Q. Okay, so Q. You're kidding me. How is Q looking like that? Why does that doesn't make sense? Well, Q start with 0? I'm pushing. Wait, what? Wait, what? Hold on. So one thing for sure. Let's use this. Actually, I think I copied the wrong thing. Yeah, I copied the wrong thing. But it doesn't have Q poll. What's this error? May produce no pointer. Yeah, that's fine. That is fine. Q will not be null. All right, let's reset this thing. Okay, Q. Hey, how is the Q after it produces 0, 0, 1, 1? How is that possible? Okay, what is this push? At the head of the deck. My lord. Alright, it's API issue. It's API problem. Wait, what? That is still not right. Gosh. Alright, let's see. At least the Q. Okay, the Q is right. Alright, the Q is right. And Q dot at last. So what's S? S is 1. 1 is not equal to Q dot push. Oh yeah, this is not right. This is not push. This is at last. There you go. Ugh. No, the API and the stupid API. Alright, I'm gonna say the API for deck is add last and pull first. It's add last to append a value, not push. Push adds the value at the left, at the front. Okay, is there a better way than just doing this? Simulating, yeah, is that another way? Counting, okay. Every student in Q receives a number of Q, yeah. If none of the students in the queue's preference matches, none of the remaining students can eat. If none of the students in the queue's preference, utilize observation to develop a constant space solution. Like a what? Like a sliding window? I don't know. I mean, it's because it has to be a 1 0 0. So we find a 1 0 0, and then we need to find a 0, right? And yeah, we can say okay 1. Then we need to find. So I think basically we need to order this, right? We order this such that it can become like this. So we can say in this case, we can do 0, 0, 1, right? 0. 0, 1, 0, 1, 0, 1. Hold on, I don't know. Students who prefer circle sandwich and numbers, then we iterate through the available sandwiches in the stack. If the top sandwich is a circle, we serve it to a student who prefers circle, by incrementing. If the square, we serve it to a square, incrementing. If the number of students who prefer a certain type of sandwich becomes 0 and the sandwich at the top is that. So we have a count, okay? So we just count, and then if we have this, then we reduce, and then we hit here, we don't have any. I see what the counting method is. Yeah, so this is a bad solution. It should be the counting method is the best one. Time complexity could be O(n) squared in worst case. Alright, so that's not ideal. Now what we want is a better one. So this is the counter method from the official solution. We count the number of ones and zeros in students each time a value in sandwiches is encountered. We check whether there is whether there's a student that can match. Once a sandwich cannot be matched by any student, the remaining student count is the result. Yeah, so we say int count C1, right? Int C2 is also 0 for int s of students. C1, actually no, don't do this. If s is equal to 0, C0 plus plus I, that's not C1, it's so C0 and C1, right? Else C1 plus plus. Okay, so we have a count. And then we say for int s of sandwiches, okay? If s is equal to 0 and C0 is larger than 0, then C0 minus minus. Else if s is equal to 1 and C1 is larger than 0, right? Then we do C1 minus minus. Else break. Then return C0 plus C1. Okay, let's see. This one's right. Alright, just done with this. Alright, let's take a look at this one. Maximize the profit and the salesman. Oh. You are given an integer representing the number of houses on a number of line, and numbered from 0 to n minus 1. Additionally, you're also given a 2D integer array offers, where offers I start and gold, indicating that the ith buyer wants to buy all the houses from start I to end I for gold amount of gold. As a salesman, your goal is to maximize your earnings by strategically selecting and selling houses to buyers to the maximum amount of gold you can earn. Different buyers can buy the same house, and some houses may remain unsold. Okay, you're given, so basically n integers, okay, so 0 all the way to n minus 1, and each one has an offer which just is like an interval, right? So this interval, I get a amount of gold. Is to maximize your earnings by strategically selecting. Okay, so basically, this question can be reconfigured into saying we have, so like 0, 1, 2, 3, 4, 5, right? Now we have this is 1, 0 to 2 is 2, and then 1 to 3 is 2, right? So we need to figure out a way such that we will maximize these values when the intervals do not overlap. So this one is 3, so we pick this and pick this, right? Okay, we check the second one, 0, 1, 2, 3, 4, 5, 0, 0 to 1, 0, 2 is 10, 1, 3 is 2, so it's going to be 10, so we do this. Okay. Maybe we DP this. That would be my first first line of reasoning. I just try to see if we can DP this. We can say up until, we want to find a maximum earnings, right? Maximum earnings all the way to, so DPI, I is going to be from 0 to I, what is the maximum earning from 0 to I? And what we want to find is DP5, that's what we want to find. Now, in order to calculate this one, DP5, actually no, it's not even 5, because it says it goes all the way to a minus 1, so it's just DP4. Right, so we want to find the DP4, but to find DP4, or I want to find DPI, is all the way up to I. Okay, what's the maximum profit that you can get? Now, we need to know, right, if this 5 is included in some range, right? If it's included in some range. If it's included, so we want to find what are the ranges that I is included in, right? And then we can say we'll take that range, right? We can take that range and then find out the previous one, DP into the previous one, right? That's like one before the range. And we just go through all of them and we'll be good, right? We'll be good. And you can also say that if I do not want to include the current, then, like I don't want to go through the whole thing, then you can say, yeah, if I don't want to go through the whole thing, then I will just take whatever it is, the previous one, right? Because basically I'm not part of this stuff. Okay, so now the question is, how do you find which one you are part of? That's a good question. Yeah, how do you know? So you're given a range, 0 to something. You can't set everybody in the range to have the value, right? I don't think that's possible. So if I go through, it'll be very hard to know immediately how many things. Yeah, doesn't feel right, right? Yeah, how do I quickly query through all of them? Plus, depending on how many you have, DP can actually run. Damn. So you have to go through every single one. That's not gonna work. That is not gonna work. Oh, no clue. Yeah, how do I know that if it's in the range? Alright, so we can query it. How? Right? The query, you need to query all of them. Maximum of gold. Yeah, the problem is I don't know what it's like given a thing. But hold a second. Do I even need to consider every single house? Because it's a range, right? It is a range. And if it's a range, everything in the range is considered the same. So maybe we only need to consider the front and end of a range. What do I mean by that? We will do, I don't know, start and end. No, we just need an end. Right? We just need an end. We just need the end. And to see if something has an end, because you can always say if we end at some stuff and take it, then we take it at that, right? And if we don't take it, then take it whatever it is the previous one. Okay, so what I'm saying is we will handle the offers such that the end will become the key, right? And the values will be values, or maybe if we can sort it. All right, I'm not in a good shape to think about this. I'm gonna end this right now. I'm too tired.